The first warning sign doesn't come from a factory. It comes from a test tube, a quiet signal, a tiny shift in data, a result that shouldn't be there. And the moment it appears, the countdown begins. Most people think food becomes dangerous when something goes wrong in a plant. But the truth is different. Food becomes dangerous when something goes unnoticed. And the only line of defense against the invisible is the lab. Every day, thousands of samples arrive in sealed bags and coated containers, powders, liquids, snack crumbs, meat slurries, each one treated as a potential threat. Because contamination doesn't announce itself. It hides in patterns, anomalies, and traces measured in microscopic clues. Before any scientist even touches a sample, one question already hangs in the air. What's hiding in here that the human eye can't see? The first step is almost always the enrichment phase. A tiny piece of the sample is placed into a warm environment designed to wake up any bacteria lying dormant. If Salmonella or E. coli is present, even in quantities too small to detect, this step gives them the chance to grow. Ironically, labs must help the enemy multiply, just to expose it. Once the microbes wake up, the real analysis begins. PCR machines search for genetic fingerprints, sequences that match known pathogens. The reactions happen in cycles: heating, cooling, copying, amplifying. If the DNA of a dangerous pathogen is present, even in the faintest amount, the machine lights up with a signal. A simple curve on a screen that decides whether a product is safe to eat or must be pulled. But microbes aren't the only threat. Chemical contaminants move through the system silently. Residues from cleaning agents, traces of allergens, even fraud. Ingredients that pretend to be what they're not. These require different tools. Mass spectrometers break chemicals apart to identify their structure. ELISA tests search for allergenic proteins with incredible sensitivity. Colorimetric assays detect toxins by changes invisible to the naked eye, but unmistakable to the sensor. Each test layers another piece of truth onto the sample. Then there's the threat that terrifies inspectors the most. Foreign material, not chemicals, not bacteria. Objects, things that should never be inside food. A metal shaving, a shard of plastic, a fragment of bone. Labs use X-ray analysis and magnetic traps to reveal what production lines sometimes miss. A single detection can trigger a full recall. A single miss can reach millions of homes. What makes all this remarkable isn't just the science, it's the pressure. Food moves fast. Factories don't slow down because a lab test is running. Distribution trucks don't wait for retests. Retail chains can't freeze inventory indefinitely. Every hour matters. Every delay can mean a shipment arrives before the lab's verdict does. So labs race the clock, not because the science needs speed, but because the supply chain demands it. And yet, despite all the pressure, most of the danger never reaches the public. You never hear about the false positives that prevented shipments from leaving. You never see the trays of products that were destroyed because one test revealed a hidden problem. The recalls you read about represent only a fraction of what labs catch early. Most threats are eliminated before they become headlines. But not every system is perfect. A sample might not represent the whole batch. A test might detect a pathogen only after it has already entered the market. A contaminated ingredient can hide inside a larger product. This is why detection will always be both powerful and limited. Still, the work continues. Not for recognition, not for applause, but because every test prevents uncertainty from becoming danger. Food safety isn't built in factories. It's verified in silence, under fluorescent lights, in rooms where accuracy matters more than speed, and truth matters more than convenience. And when a lab result confirms that a batch is safe, it isn't just a green light. It's a moment of relief, a reminder that the system worked, a sign that someone caught the threat before it reached your table. The story of contamination detection isn't dramatic by design. It's methodical, precise, relentless. But behind that calm exterior lies a simple reality. The safety of millions depends on a handful of tests catching something invisible every single day. We rarely think about what our food had to survive before we ever taste it. But inside every clean label and every sealed package lives a quiet proof of work, the unseen battle fought on the microscopic level. And it raises a question: as our food system grows more complex, how far will labs need to evolve to keep up with what they can't see? Because the invisible threats aren't going away, but neither are the people trained to find them.